So this question is related to topic moles, and using the mole ratio, we have to determine the value of how many water crystallizations are there or how many water molecules are attached to sodium sulfate. So in an experiment, 1.61 grams of hydrated sodium sulfate is there. That is heated until the water is given off. How we'll know that all of the water crystallization is being released? So we will heat until the constant mass, like we'll heat it until the mass of the solid remain or does not change. So the mass of the remaining sodium sulfate. So in the beginning, we have hydrated sodium sulfate Na2SO4 dot XH2O. But when we supply the heat energy, due to the heat energy, it will undergo a thermal decomposition and it will decompose into sodium sulfate plus X water molecule will be there. So they mention in the question that we have the total mass of hydrated sodium sulfate is 1.61 grams. Then the mass of the remaining sodium sulfate is 0.71 grams. So what will be the mass of the water? We'll follow the steps. That is the second part. The first one, calculate the number of moles of sodium sulfate. So we have the mass because we need sodium sulfate. So to calculate the moles, moles equal mass in gram divided by molar mass. So moles equals the mass in gram divided by the molar mass. So mass in gram of sodium sulfate only, that is 0.71. So we'll write 0.71. Then the molar mass of a sodium sulfate, we have to use a periodic table. So when you check for in a periodic table, we have sodium, which is 23. So we need the mass of sodium sulfate Na2SO4. So sodium is 23 multiplied by 2. Plus sulfur is 32, as you can see here, sulfur, which is 32. Plus oxygen is 16 multiplied by 4. So this will be 46 plus 32 plus 16 multiplied by 4, that is 64. So 64 plus 32, that's 96. 96 plus 46. So 142 is a molar mass of sodium sulfate. So we calculated the molar mass, that is 142. So 0.71 to get the mole divided by 142, that is 0.005 moles. So these are the moles of sodium sulfate which are produced from hydrated sodium sulfate. The second is calculate the mass of water given out. So how to know the mass of water? The total mass of hydrated sodium sulfate is 1.61, where the mass of anhydrous sodium sulfate is 0.71. So what is the mass of water? So 1.61 minus 0.71, which is equals to 0.9. So we'll have 0.9 grams of water will be there. So it's 1.61, the total mass of a hydrated sodium sulfate, minus the mass of anhydrous sodium sulfate, 0.71. So when we subtract, we'll get the mass of the water which is released. Then calculate the number of moles of water. We have the mass. So how to work out the moles? Again, we'll use the same formula that we use in the first part, that moles equals mass in gram divided by molar mass. So mass in gram of the water, that is 0.9. Where the molar mass of water H2O, you will again use a periodic table. In a periodic table, mass of a hydrogen is there 1 and mass of oxygen is 16. So mass of the molar mass of 1 mole of water, which is 1 multiplied by 2 plus oxygen is 16. So it is 16 plus 2, 32. So this will be 32. So 0.9, by mistake, because here 2 is there plus 16. So that is 18. So this will be 18, not 32. Only molar mass is there, so 16 plus 2. So 0.9 divided by 18, which is equals to 0.05. So we get 0.005 moles of sodium sulfate Like we got 0.005 moles of sodium sulfate and we got 0.05 moles of water. If we want to take the simplest ratio, so how we take a simplest ratio to know how many water crystallization are there? So we divide by the smallest value. So the smallest value is 0.005. So if we divide both of them by 0.005, this will be 1 and this is 10. So means here we have 1 mole of sodium sulfate and we will have 10 moles of water. So what is the value of X? Because the last part is calculate the value of X. So X equals to 10. As you can see here, the last part determine the value of X. What is X? X are the simple mole ratio of water which are used. So how we work out the value of X? We have the moles of sodium sulfate, we have the moles of water. So we divide by the smallest value, which is 0.005. So as we divide by 0.005, the ratio will be 1:10. So X is equals to 10. So this is another question which is related to the stoichiometry, the calculation part. So many organic compounds contain carbon, hydrogen, and oxygen only. An organic compound V has a following composition. Like these are the percentages that this compound V, it contains carbon, it contains hydrogen, and it contains oxygen. I'm writing on the right hand side, carbon is there, hydrogen, and oxygen. The percentage of the carbon is 48.65. The percentage of hydrogen is 8.11 and percentage of oxygen is 43.24. These are the percentages. What we have to do, we have to determine the empirical formula. How to determine the empirical formula? Step 1. What is step 1 if you want to determine the empirical formula?
Divide by atomic mass.
So we'll divide by atomic mass, relative atomic mass. So using a periodic table, you can either, once you are in practice, you will remember these masses. But if you are not, you can use a periodic table. So for carbon, you'll find it is 12. For hydrogen, it is 1. And for oxygen, it is 16. So using a periodic table, so carbon will be divided by 12, hydrogen will be divided by 1, and oxygen will be divided by 16. So 48.65 divided by 12. What's the answer?
4.054.
So it is 4.054. We prefer to write like three decimal places. So it's 4.054. 8.11 divided by 1, it will remain 8.11. And 43.24 divided by 16. What's the answer?
2.702.
43.24 divided by 16 is 2.702. Okay. So this is step 1. Step 1, we divide by atomic mass. Then we move on to step 2. What is step number 2? In step 2, we divide it by what?
Smallest value.
So we divide it by the smallest value in the combination. So which one is the smallest value in this combination?
Third.
The third one, 2.702. So what we'll do, we'll divide each of them by 2.702. So if I divide 4.054 divided by 2.702, what's the answer?
1.5.
1.5. Then 8.11 divided by 2.702. How much? What's the answer?
3.
3. And then this will be 1 because we are dividing with the same. If you remember, as I mentioned, if one of the values like 1.5, 2.5, 3.5, then what should be your step, the last step? You make this. Yeah, we multiply all of them by 2. So one of the values 1.5, 2.5. So we'll multiply all of them by 2. So this will become 3, this will become 6, and this will become 2. So what is the empirical formula of this compound? It contains C3, it contains H6, and it contains O2. So that is the empirical formula. Is it clear, the empirical formula?
Yes.
Then the second part is the compound W has an empirical formula. CH4O, the another part. Then the relative molecular mass is 32. What is the molecular formula? So how to determine a molecular formula? The molecular formula equals empirical formula times N. Empirical formula multiplied by N will get the molecular formula. And what is N here? N is the molecular mass
divided by empirical mass.
Divided by empirical mass. So the molecular mass is given already in the question, that is 32. So we write 32. What about the empirical mass? Empirical mass is always from empirical formula. So this is not related to the previous question, like there's another compound W is there. This is empirical formula of compound V, but this is another compound W is there. So which is CH4O. So what is the empirical mass? Empirical mass will be carbon 12 plus hydrogen 1 into 4 plus oxygen 16. So it will be 32. So 32 divided by 32, it means N is equals to 1. So whenever empirical and molecular masses are same, the compound will have the same empirical and molecular formula because N is 1. So when we solve, it is CH4O and value of N is 1. So this one is multiplied with carbon, this one is multiplied with hydrogen, and one is multiplied with oxygen. So the final answer will be CH4O. So it is the same because whenever empirical and molecular masses are same, the ratio will be 1. And if 1 is multiplied by empirical formula, we'll get the same answer. Is it clear discussion of finding the empirical formula and finding the empirical molecular formula for compound?
Yes.